Good morning, everybody. Apologies for the slight delay there. I hope the exams so far have gone well for you. You're well into the swing of things now at this stage. You've got a week under your belt. And it's great to have the weekend before we have the Ag Science paper on Monday to get a little bit of extra revision done. It's an early start, I know, but it's good to get up and going and make best use of your time. Apologies to any of those German students who are out there doing German this morning, but hopefully you'll be able to catch up on the recording over the weekend. In today's class, what we want to have a look at is our exam timings. Just look at a little bit of our technique around those exam timings and what we have to do. And we're also going to delve into the cross-cutting themes to things like health and safety, technology, sustainability, food production, because I think that's, it's a good way to glean an overall view of the course here today, look over certain things. And as always, if there's any questions that you have, get them up here, okay? We'll leave plenty of time at the end to answer any questions you may have and see if there's anything we can do to assist you guys over the course of the weekend and in the run into that Leaving Cert exam. You'll see here with our exam guide, and these notes are up as well, the paper is split into two sections, Section A and Section B. Section A is the short questions, it's worth 100 marks in total, and Section B is our long questions, that's worth 200 marks in total. And out of these, we've also got our IIS, which is worth 100 marks. So 400 marks in total. That IIS is worth 25% of your paper, and the written elements here are worth 75%. In Section A, we've got to answer 10 out of 12 questions. So within the 12 questions, there'll also be some internal choice as well. Can I encourage you, I think the nature of the paper where you fill in boxes, you get through those fairly quick. We've allotted 5 minutes time for each question. But you should get through some of those questions pretty quickly, particularly the ID and some of those elements there. So try and answer everything on the paper. Try and answer 12 out of 12 questions. Try and answer some of those internal choices. They'll mark everything. They'll take your best 10. And I think that's how we can maximise our marks going through. Within that Section A, we often see some of our experiments, or SPAs. We'll talk about the importance of those. We'll see a little bit of animal and plant ID coming up there as well from time to time. Areas like catch crops have shown up, and there will be things in the paper, guys, that you haven't seen. Like last year there was a question there on agroforestry in the short answer questions, but actually what they're examining there is a skill. Can you look at, there was a little piece about agroforestry, can you analyse that, can you draw out the key information and the points from that? So they're really looking at some of the key skills that you've built up over the course. So don't panic if you see something that hasn't come up, that hasn't been covered in the course of your classes or in the grinds here. It's probably just testing those skills, and you can apply your knowledge. With something like that agroforestry question last year, we've learned about maybe trees and hedgerows and farming in the environment, and we can apply our knowledge from those to put those principles in. So as I said, 5 minutes per question, about 50 minutes in total, but that should give you plenty of time, okay, to read over and to get as many of those questions answered as possible as well. Section B are the long questions, and we've got to answer 4 out of 6 there. Each question is worth 50 marks in total, so you see 200 marks in total here in the question. And again, if we can, answer as much as we can there through. This could bring in anything from SPAs. Often what we'll see is sort of questions integrated a little bit. There might be a little bit on soils, there might be a little bit on crops, and there might be a little bit on animals there, as well as the cross-cutting themes in. Last few years, there's often been a full question on genetics has come in there as well in the long questions. So really, it's hard to narrow it down to areas because of this non-linear approach that we get with the questions there. So plenty of practice of past paper questions, seeing how things link in together. As I said, the SPAs is a crucial part there. And there may be an unseen SPA where you're asked to pick out, what might the hypothesis be here? What might be the independent variables, the dependent variables? So general principles as well of good science investigations may come in within that area. We're allowing about 25 minutes per question there, okay, so 100 minutes in total, and you see that brings us over. I'm allowing a little bit of time there as well for the review at the end. You'll probably take sort of 20 minutes a question and give yourself a little bit time of review. So key focus areas now for the weekend. Experiments, I've mentioned those a few times, okay, that's a key one for me. Look over the SPAs, there's videos of all of those up there on the platform. There's should be fairly comprehensive notes up there on them as well. So take the time to go over the SPAs and make sure you know them. Within the SPAs, we haven't dwelt too much on the genetics one. I'd be hoping you don't see that hybridization because it's not an easy one to come in. And don't forget to look over the farmyard layout and plan as well. That was maybe something you've done in class. Walter has a really good video going through his farm. Take a look at that over the course of the weekend, just to familiarize yourself with some of the features and everything that go through there. You know, dairy and grassland are two really key topics for me. I think they come up a lot. They'll come up a lot together, and a lot of the livestock questions we can answer around that dairy management there. So if we were trying to prioritize stuff, okay, I'm not making any predictions here, but I'm saying these are key areas that we could go over. Soil management, tying together all those soils. A lot of the soils questions are born out of, again, those SPAs as well. So knowing all the SPAs around soils, things like organic matter, infiltration rate, maybe with organic matter, you know, they've brought up things like the calculation there every year, working out the percentage carbon, multiplying by 0.58. And certainly the nitrogen and carbon cycles, those things have come up quite a bit in the years as well. Calculations, again, there's a video up on the platform there, there's notes up on the platform too, going through each of those calculations. These are just areas where we can glean extra little marks outside those you know, core questions and core topics that come up. And animal and plant ID, I said that probably comes up more in section A, but there was a few bits, certainly looking at grassland species and everything in section B last year as well. So I figured out there was about 20 to 30 marks going there, and it mightn't seem big in the overall course of things, but that can be anywhere from 5 to 10% on each of these little areas. So just a few key tips there, I suppose, as we're going through. Make sure you take the time to read everything through thoroughly. Don't panic when you see things. Often these questions are about applying your knowledge, okay? Plan your long answers. Take a little bit of time with that. Use bullet points where you need, these diagrams where you need. Look at those key adjectives as well. Are they asking you to outline? Are they asking you to list? Are they asking you to explain? And that'll give you a sort of idea on the level of detail you have to go in with each of those. Use the agricultural terminology accurately. You know, I think in the last class I talked about fertilizer and people talk about spraying rather than spreading. You know, farmyard manures and slurries. What are those sort of misconceptions? For those of us not from a farming background, make sure we're getting that terminology in, but also that we're accurate with it. We're using it in the correct, I suppose, syntax and terms and everything there. We're getting correct with those as well. Diagrams, maybe if we're asked to write up an experiment, putting a diagram in, marks can be taken from those. If we're asked to draw something like the nitrogen carbon cycle, sometimes we get these beautiful drawings coloured in and everything, but no labels around them. Generally, if we get a diagram like that, there'll be 3 marks going for the diagram, 3 marks going for labels, 3, you know, so it's split up fairly evenly. So get those in. Again, if we're doing a graph or a table, make sure we label the axes and make sure we have those numbers very clear. Everything is drawn to scale. Think of those tables. We talk about salt sometimes, scale, axes, label, and put a title on it as well. Don't leave blanks. Try and get everything through. Don't leave yourself with time at the end. Don't leave the exam early. Take your 2.5 hours. Make sure you try and get through everything there. Get on top of it all. And, you know, the past paper questions, we keep on coming back to that. In the full book of notes and in the book we have here with Ag Science, there's all the past paper questions. There's all the marking schemes in there as well. You can see exactly what the examiners are looking for, what they expect from you, what sort of level of detail they expect as well, and how those marks go. All right. So guys, those are just a few key things on the technique and everything that goes with it. So just make sure we're giving it everything now, a push over the weekend. And as I said, our main focus today is going to be to have a look at the cross-cutting themes and the notes and everything that comes with it there. So I've put up 2 different sort of notes. There's infographic ones here for those of you who prefer the bright colours in the pictures. And we've also got a fairly comprehensive set of written notes there in the cross-cutting themes as well. So there's something, you know, last day we talked about topical issues that come up. Cross-cutting themes would sort of cover in with that. It's keeping the Ag Science course relevant. It's keeping it up to date. It's keeping going with it. And with health and safety here, health and safety is a huge issue on Irish farms. You know, it's one of the worst workplaces for work-related accidents. And that can be anything from dangers through livestock, dangers with slurry is a big one, PTOs on tractors, dealing with chemicals. And particularly given the sort of multi-generational that we find on farms, A lot of these accidents happen amongst very young children and also amongst these older farmers and stuff. People who are maybe saving a few quid trying to do a job themselves, cutting corners on bits and pieces, or maybe just not assessing a job properly before they get into it. So health and safety is paramount on farms, and our awareness around health and safety is pushed hugely by the HSA, by Farm Safety Authority. We're really trying to minimise the risks, the injuries, and indeed the unfortunate deaths that take place on farms every year. And what we want to do, I'm going to split it up into soils. So we have a sort of a feel of our soils, crops and animals, and let's just take a look at a few of the safety considerations that come in with each of those there. In soils, the big one is slurry. Now, slurry is the liquid feces and urine that we capture in big tanks underneath slatted units. And what happens to the slurry when it's stored over the course of the winter is it cakes. And that means it forms a hard crust on the surface there. So we form this hard crust on the surface. And what we have to do is we have to break that crust by agitating it. But when we agitate's like a big whisk on the back of the tractor. When we agitate that, when we break up that crust, what it does is it releases toxic gases. And it's the release of these toxic gases, just a breathful of these toxic gases can kill someone immediately. I'd always talk in my classes, there was the really unfortunate, it's about 10 years ago now probably, there was an Ulster rugby player, Nevin Spence, and they'd cleared out the slurry tank, everything was gone, they'd taken everything, but there was still gases trapped down into it. Their dog went down in, he was suffocated. The dad went down to try and get the dog out, he was killed. Nevin's brother went down and Nevin himself, and all three men were killed by those harmful gases that came from that process. So when we're agitating, when we're breaking up that crust on the slurry before it gets spread out, we have got to, I suppose, make sure we've got to clear all livestock and people. We've got to make sure the whole area is well ventilated. Generally, if we do it on a cool and windy day, we'll have that dispersal of grasses, and we've got to take the time. The agitator is running off the back of the PTO on the tractor. Really, you need to step away out of that area the whole time, cordon that area off, make sure that agitation process takes place without any real problems there. Now, I'll just pull the notes back up again there. Perfect. So slurry and that slurry agitation, that's one of the big points. So having those proper agitation points, looking after them. Now, one of the key things I mentioned was working here with the agitator was a PTO. And particularly with our crops, we have machinery and the PTO. And the PTO is a thing that comes out of the back of the tractor, okay, and it drives the machine that's going behind that. So whether that's a slurry spreader, whatever that may be, okay, that PTO drives and it moves at thousands of revolutions per minute, okay, about 540 RPM, revolutions per minute, that's spinning around. If you get any loose clothing caught in that, if you get any hair caught in that, if you get a limb caught in that, it often means, okay, that farmers are losing limbs and it can cause severe accidents, injury, and in some cases death. So with the PTO, we've got to be very careful of machinery. We've got to make sure all machinery is operating properly. And we've got to turn off all machinery before maintaining or serving. So before maintaining it or servicing it, you know, often where these accidents occur, A farmer might, find there's a blockage in something like a diet feeder or a baler, not turn off the tractor fully, hop down, the PTO is still running, cause, a bit of loose clothing or something like that gets stuck in it. And this can be severely debilitating injuries come from that as well. So the PTO with tractors particularly, but with all machinery, we've got to make sure we're operating it properly, we're operating it safely. We've got an experienced person in there as well. You can get your tractor driving license at 16. So, we've these 16-year-olds going out with big 140, 50 horsepower tractors and more, and big 20-ton trailers behind them. We've got to make sure that everybody knows what they're doing and how to look after that machinery safely. The other area I suppose we come across with crops is chemicals. And chemicals, anything from weed killers, the last day we talked about pesticides, herbicides, insecticides, all these different types of weed killers that we come across. They can be very damaging to health, to skin, they can be irritants, they can be toxic, they can be poisonous. So with our chemicals, we've got to make sure that we store them correctly. And then we've got to have the proper protective gear. We've got to have masks and goggles. And we've got to make sure that the machinery we're using to spray or to use these insecticides, pesticides, herbicides, whatever they are, is correctly calibrated and we're looking after it properly. So in each of these areas, we're trying to give you some of the health and safety risks that come across. And you'll see there's there in the notes as well, guys. Chemical use we've put in, the machinery and PTO we have in there, slurry agitation. If we just go into the risks on the farm, we see a lot come from tractors, farm vehicles, everything like that. Machinery is a huge part. Draining gas, unfortunately, and that's the other thing I should have mentioned with slurry. If we have an open slurry pit, so these slurry pits here where we're talking about agitating, they're tanks that are kept underground. They're relatively safe, but an open slurry pit or a slurry lagoon, if someone falls into that, there's a risk of drowning, a huge risk of drowning. So having those fenced off properly, making sure, again, particularly children can't get near it or they don't chase a ball into it or something like that, because drowning is almost inevitable with the viscous nature of the liquid that's in that there. So with livestock then as well, we'll just look at our last one with animals. You can see that on the board with it. The big thing with animals is the very, you take something like a fully grown cow, could be anywhere up to 600, 650 kilos. A bull could be anything up to a ton in weight. These are huge animals. Even coming back down to a sheep farmer, a ram could be anywhere up around 120, 30 kilos. These are big, heavy, powerful animals, and we've got to make sure we look after ourselves, but also the animals in these situations, particularly when they're handling them. So with animals, we've got to make sure that we have proper handling facilities. With the likes of sheep, we have a sheep race, which just brings them through. This causes less stress on the animal. It's easier on the operator as well. It means sure he's outside when he's doing it. He's not in the pen with the animals. Likewise with cattle, we have a cattle crush, a headstock. So these are things, having these proper handling facilities, they're much safer. They'll reduce labour requirements there as well because you're working through, and they reduce the stress on the animal as well. So having those proper handling facilities is really important as well. I suppose the big danger in the farm, and you'll see that there with the livestock notes, is a bull as well. I said a bull could be anywhere up to a ton of weight, a really big continental bull there. So we've got to make sure that if we're entering the field, we're safe at all times. We know what our exit routes are. We're probably in a vehicle to make sure when we're moving that, we're safe at all times as well. And I think another huge area with livestock fatalities and injuries or fatalities to the farmer from livestock is a pregnant cow or a cow that's just given birth. So a cow that's given birth is hugely protective of her calf there, should be looking after it. Really, she could do serious damage there in an effort to protect her calf. So having proper, again, calving gates, not going into the pen with that if we're disbudding the animal or anything like that. or tagging the calf, making sure we're separating the cow and the calf so that she can't do any damage while she's trying to look after that there. I just have a look at the notes here. Another big thing that can come up is the farm safety symbols. Okay, so particularly if you're part of any of the different schemes, be it farm safety schemes, right down to Origin Green, some of the Board BIA sustainability schemes, farm safety is a huge element of those, and we've got to display on the farm these farm safety notices. You'll see things like livestock there, farm machinery, not a playground. We talked about the younger children on farm and being aware the whole time. If you're up in a big tractor, it can be very hard to see children running around the farmyard or anywhere beside you. The risk of draining that might come from open slurry lagoons or slurry tanks, the harmful fumes that we might come across inside tanks, and indeed combustible gases there as well. And you'll see some of the other ones down the bottom there. Beware the bull, guard dogs, farm machinery, chemical stores. We'd have to have one of these symbols on the chemical stores and maybe shown that's an irritant or toxic. So probably with your laboratory safety symbols, you'll remember a lot of those from Junior Cert. But there's a different set of symbols here, and they have been, particularly on the ordinary level paper, they have been examined from time to time. So being aware of those farm safety symbols is important as well, guys. Now, technology. Just see, I can't get rid of that side screen there, but hopefully you'll be able to see that. Technology was the theme of the IIS this year. It was looking at new technologies on farms. Now, technology, we tend to think of something digital. We tend to think of drones, we tend to think of moo calls, we tend to think of all of that. But new technologies as well, I suppose, when we're looking at agriculture, that could be anything from protected ureas, it could be using clover. I suppose those are we refer to new ventures, new technologies that are coming in the whole time. So a huge amount of the work done by Teagasc looking at reducing water runoff, reducing fertilizer usage, all of those we refer to as new technologies as well. So just bear in mind that IIS title, because there's often a few questions around it as we come up there on the paper from year to year. So technology, I suppose technology on the farm reduces labour, it reduces time, it's more sustainable in terms of both of those, economics and everything like that, okay? And it can also reduce our inputs or costs overall. So those are our advantages of technology there, okay? A big one as well would be precision or accuracy would come in to that as well. So our precision or accuracy is very good there. I just realised you probably can't see any of those now. That's my fault there. Okay. So with something like our inputs or costs, you might be reducing fertilizer usage there. So if you're using GPS in a tillage farm and a drone to pick out exactly what areas need maybe fertilizer or a pesticide, a molluscicide like slug pellets or something like that, rather than just spraying it over the whole field, you can identify different areas there that come through. It can increase output. Okay, we can get higher yields, better yields from it, and that's going to increase our profitability ultimately at the end of that. And anything that can reduce labour or reduce time, so maybe using robotic milking parlours, so the farmer's not up the whole time, not going the whole time, cows can come in, they can milk themselves, this would up the milk yields, up the level of production again, and reduce the labour and reduce the time that's spent on it, so socially very sustainable as well. I suppose some of our drawbacks is the investment costs. So we'll just say high costs. Okay. And technology, as you know, if you have a laptop or an iPhone or anything, it can break down. And when it breaks down, you need someone who has expertise to fix that back up. So With technology, what I want you to know, what are some of the advantages of it? What are some of the disadvantages? And again, this is where I said applying your knowledge. Like I remember one year in the paper, there was a question came up about wireless fencing. Now people were like, we've never looked at wireless fencing. But actually what the question asked is, what are the benefits of wireless fencing? Well, we could say in technology, it reduces labor, it reduces time, you know. What are the disadvantages of this? We could say, well, it's a high cost to set up. Technology could go wrong and the wireless fencing could break down. So apply that knowledge the whole time. Bring that knowledge through the whole time that you're looking at there. Some of the examples of technology you can see there, precision agriculture. We've talked about things like GPS. So GPS in a field, maybe some of you have been watching Clarkson's Farm recently. He's got the GPS on the tractors there. It makes sure we're not sowing or fertilizing or ploughing or harrowing the same area twice, okay? So it makes it much more efficient in where we're moving. It maps the field, and GPS will, in most cases, guide the tractor there as well, drive the tractor. Drones could be used for direct and indirect control. Indirectly, they could be used to monitor crops, to check crops. Maybe they could be used to scare away birds and pest control as well. And also for direct control, they could be used for possibly spot spraying, spot fertilization and stuff like that, rather than fertilizing wide areas there. You'll see in terms of animals, technology, we've got things like the robotic milking machines that we've mentioned already, those automated milking machines there, reducing manual labor, reducing the time element in the farmer, shortening his working day a little bit and allowing him concentrate on different areas like feeding and so on that goes with that. Ones that have come up in the past there as well are the activity monitors that we sometimes see on dairy cows. So those activity monitors would monitor their general movement. It would tell the farmer based on that movement and temperature when they're in heat. It would also flag with a lack of movement maybe if the animal is a little bit off or carrying some sort of illness or sickness. So milk yields, everything come in that. So it's producing output, it's producing data for the farmer that will allow him make informed management decisions. And it's producing that extra level rather than just maybe a visual check of the animals every morning, what they're coming in. So heat detection aids would be another huge one there with technology, and that crosses over into our genetics as well. Okay, getting those heat detection aids right and set up is really important. The other one that's come up in a paper in recent years is the moo call. And the moo call goes on the tail of a calving animal or an animal that's about to calve, so onto a suckler or a dairy cow. And as the tail moves, as the cow is preparing for calving, it detects that change in movement, okay, and it will send a text to the farmer when the cow is about to calve so that he can monitor that calving and make sure that everything runs smoothly. So particularly for part-time suckler farmers, that moo call is hugely beneficial there. You see a few other things like smart farming apps we've put in there, renewable energy, vertical hydroponic farming, and increasingly we're looking for farmers to become more sustainable and to protect the environment. And technology is one of the ways that farmers can produce more sustainable. We've talked about reducing fertilizer, reducing costs, reducing the use of pesticides, reducing labour. All of these are sustainable measures, but also the environmental cost of reducing fertilizer means it's not getting into water courses. Precision agriculture and drones, we're using less inputs. So a lot of these cross-cutting themes, they tie in together as well, and we've got to get our head around that and see how they sort of interweave and interlink and use that knowledge to get those good answers in. All right. Farming in the environment, that's one that we mentioned there. Okay, and I suppose, as I've said, environment is a huge area at the moment. Protecting that environment is a huge area at the moment. And I'll just pop back up on the board here for a minute again. With environment, I suppose a few key areas that we have at the moment is reducing emissions, improving water quality, and the other one that we're having a look at there at the moment is biodiversity, enhancing biodiversity. So with our biodiversity, I talked earlier on about agriculture, okay? That might be planting things like hedgerows, planting trees on the farm. And as a farmer at the moment, through schemes like the EOS scheme, okay, GLOS, there's various different schemes out there. There's older schemes and newer schemes, but environmental incentive schemes where the farmer would get money to plant hedgerows. He would get the cost of planting trees on the farm. He would get, if I plant trees on the farm, I'm going to get a premium every year from those, as well as the final harvest that comes through. So we're putting in, and the EU are putting in through CAP, huge financial incentives to get farmers up and going, to get them going with that. I just see a few questions coming in, guys. I'll get to all the questions at the end, okay, and I'll answer them through as well. So hedgerows, trees provide habitats. That could be anything from ponds to bird boxes, bee boxes, anything like that that we can do to enhance biodiversity on the farm. And what's the other big benefit of planting things like hedgerows and trees and replacing and removing them is it all leads to carbon sequestration as well. So it's absorbing carbon, it's trapping carbon in, and it's reducing these things, the emissions. So in terms of reducing emissions, really what we're looking at is these GHGs, the greenhouse gases, and CO2 is a big one there, and then CH4, which is methane. And most of that methane it's a byproduct of the rumination system in the animal. So the CH4, the methane, comes from ruminants. Cows and sheep are getting a hard time at the moment. We're talking about maybe reducing our national herd. 33% of our overall emissions in Ireland come from agriculture. And we're failing ultimately at the moment to reduce these emissions. I think agriculture is doing fairly well, but overall as a country, we're not meeting our climate targets. With the ruminants, we're looking at things like extending the grazing season. So at least if they're out on grass more of the year, you reduce those emissions. You reduce ammonia emissions and stuff as well from housing them. We're looking at alternatives like seaweed in the diet. They can reduce the methane as well. And we're also looking to genetics, things like EBIs and the other indices there that can produce basically a more efficient, a better cow, or maybe the sheep improvement scheme, a better sheep or whatever as well, that's going to be a lot more efficient at bringing that through. I'll come back to greenhouse gas emissions in a bit. We'll have a look at it on the thing. Now, improving water quality, this is a big area as well, because what we have is we have runoff from things like slurry, from fertilizer, and also that slurry, that fertilizer, we also have a little bit of an issue there as well with silage effluent from time to time. Okay, and our problem with those is they're nutrient rich. And if we have these nutrient rich, basically fertilizer getting into our water streams, it causes algal bloom. So it causes a huge overgrowth of the algal bloom. The water course, the river, the pond, it can't sustain all this algae. So what does it do? It begins to die back, it begins to decompose. And as it decomposes, it uses up oxygen, O2, and that can lead to a thing called eutrophication, okay, where we use up the oxygen in the river, and it's that leads to fish kills and everything that goes with it. Sorry, my screen's just gone here again. I'll just cast it back. There we are. So sorry, 1 minute. So we just talked about how technology can go wrong. Technology is going wrong on me there. So water bodies, you can see there, we talk about water bodies, okay, the water quality is really important to us, and this is a huge topical area at the moment, particularly with dairy farms. So there was a question on water quality last year. Might be no harm to look over that again. I don't know whether you'd see a question like that again, but water quality could come up somewhere, or even to display your knowledge of agriculture, talking about that water quality would be really important. But we've got to protect ditches, streams and rivers from any sort of runoff getting into it. So Under the nitrates regulations and directives, we talked about those the last day with soil management. We can only spread or spray at certain times of the year. We can't spread near to water courses. We can't spread or spray when there's waterlogged land. Like I know down in Wexford yesterday, I got an alert out to say there was a yellow rain warning. You shouldn't be spreading slurry effectively at this time. Okay, so when water courses land frozen or waterlogged, but also we can create these buffer zones, maybe through planting trees around by water courses, by fencing off water courses, by leaving wildflower margins around water courses. That's one way that we can sort of protect any of these nutrient-rich runoffs from getting into them. Hedgerows and trees there you'll see an increase in biodiversity we've talked about as well. But just the greenhouse gas emissions, I've actually taken that, guys, directly from the Markin scheme there. But you'll see methane, nitrous oxide, carbon dioxide are key ones there. Animal digestion, we've mentioned. Manures and slurries, I didn't dwell on too much, but the big one there we talked about with soil management the last day is the LESS system, the low emission slurry spreading system, for getting those out, okay? Following the nitrates directives there with that. Fertilizer usage, soil test. Don't use fertilizer just for the sake of it. Use the correct fertilizer for the needs of your soil. Get that nutrient requirement right. And you'll see there forager feed, increasing the grazing season, getting them out in grass, which is a growing crop, which is absorbing carbon dioxide the whole time, reducing concentrates because the whole production process with those is using carbon dioxide and everything that goes with it. Now, sustainability. So Cian, I'm saying, where are the infographic notes? I think Thailand has just put them up on the platform there. Okay, so those infographic notes should be up there. If there's any issue, just let us know, give us a shout in, and we'll get the support team here to make sure everything is up and right. Okay. Noah, what would you be studying from now till Monday to increase your grade? I think I've sort of chatted through a few bits like that. You know, for me, Noah, it'd be going over the SPAs, going over your experiments, making sure you can do all those calculations. Dairy, grass would be a key area. Soils tie in a lot, as I said, with the investigations going through there. You've got to do one crop. We looked at barley. You've got to have a catch crop, could come up in the short questions there as well. So we looked at kale. So try and focus in on those key areas there, I think, as well. Sustainability, in our last two topics, we've mentioned a lot about sustainability. So, you know, we talked about technology, how it can help. We talked about farming in farming with nature, okay, and coordinating with the environment to try and get that right. So a lot of the things that come up here with sustainability we've seen already, things like precision farming, using the GPS and drones, okay, reducing fertilizer, test the soil so we know exactly what we need, make sure the soil pH is correct, that's really important. Liming the soil will get the soil to its correct pH, and if a soil is at its correct pH, they'll get much more uptake of nutrients. What are our alternatives to synthetic fertilizers? Red and white clover are nitrogen fixing. They have rhizobium bacteria in their nodules there. They'll fix atmospheric nitrogen and turn it into usable nitrates. Likewise, a lot of multi-species swards and stuff have red and white, well, red clover if it's a silage mix, white clover if it's a grazing mix in it. Protected urea, that's got a urease inhibitor in it. So when we spread it, rather than volatilizing and losing ammonia emissions to the atmosphere, that causes the urea to break down more slowly and actually make sure it gets into the ground as well there. And the use of organic manures, farmyard manure and slurry. Again, with the last class, we spoke a lot about that. Okay. Biotechnology advancements. We'll look at genetics in a bit. Genetic modification, we don't really have genetically modified crops, okay? But through selective breeding, through EBI indices, beef indices, through sheep improvement schemes, we're trying to breed more efficient stock. And likewise, we're doing that with crops. We're trying to breed crops with greater disease resistance, okay? Better yields, better suited to our current environmental conditions. That's going to reduce inputs, improve productivity, doing everything in a sustainable manner. Soil health would be a key area around sustainability as well at the moment. In soil management, 2 weeks ago, we talked about min-till, so not ploughing the soil, not releasing the carbon that comes from there. Using LES, okay, LESS systems, low emission slurry spreading. This is the sort of terminology where you can show I'm an agricultural student. I'm on top of it. I know what I'm talking about. MSS, multi-species swards there as well, okay? And anything really that adds organic matter to the soil, biostimulants that might improve bacterial and fungi action in that soil, and minimizing soil disturbance would be a big thing as well. Organic farming, I just need you to know the definition of that. Organic farming has come up a few times. That's farming without the use of chemical inputs and medicines. There's a big push to get more and more farmers to go towards organic. Your productivity might be reduced slightly, okay, but you get a much greater price for that niche and artisan food that you produce from organic farming systems. And increasingly our consumers are looking for that food that's produced under a certain way without the use of chemicals or without the use of medicines or whatever. So, you know, I looked at it. I haven't got into the organic system yet because with sheep, it would mean with something like fly strike, I'd have to treat it topically rather than using, at the moment I'd use something like Click or a Puron, which just gets rid of those maggots and those problems altogether. So you'd have to work a system, okay, that works within that organic system, find out what works for you. So, you know, there is a push for a lot of farmers to go to organic, and it does suit maybe a lot of our smaller livestock farmers, part-time farmers, with everything that's going on there. So Katie, you're asking about soil profiles. Katie, yeah, you do need to be able to draw the soil profiles. There's 3 key ones I'd look at. I'd look at the podzol, okay? So the podzol, I mean, white ash, okay, because we get that bleached layer and we get the iron pan. I'd look at a brown earth where there's no discernible layers through it, okay? And that's the easy one to draw if you're just asked to draw any named soil profile. So a brown earth, a podzol, and the other one I'd look at is gley. And we've got to know about the iron pan, the impermeable iron pan with the podzol, and with gley, we've got to know a process called glaciation, okay, the formation of a gley soil. You'd also need to know, probably the questions you get around the soil profiles there are, what are the uses of them? You know, can they be, like a brown earth can be used for anything. A gley soil, probably we're looking at forestry or something onto a gley soil. Whereas with the podzol, we'd have to put in drainage, or we'd have to use a subsoiler to break up that iron pan, that impermeable layer, to make sure that we could use it for maybe a permanent pasture or something like that. So certainly, Katie, that's something I'd practice, drawing a very simple little diagram of it. You know, again, label it properly, show your distinct horizons, A, B, C, and the subsoil there. And all of those 3 key ones and notes on them are in the notes booklet or in the textbook as well. And again, if there's any additional information you need on, just email me, Ian, IAIN at Grinds360, get a question up here, or speak to the support team, and I can get those notes up and going over the weekend. Now, breeding and genetics. So with these breeding and genetics here, you know, again, this is a full 2 chapters looking at reproductive systems and everything. But I suppose breeding and genetics ties in because of that sustainability we just talked about. Some of the technologies we just talked about. How can we make farms more sustainable? How can we reduce labour, reduce cost? How can we, you know, really with farming, what we're trying to do at the moment is increase outputs, but do it in a more sustainable manner. We've got to produce more food than ever before, but we've got to look after the environment, and we've got to do it sustainably as well. And you'll see here with our genetics, there's a few sort of key definitions I've put in. You know, genotype is the genetic makeup of an animal. Phenotype, pH, is the physical makeup of an animal there. But really what we're looking at here is some of the more applied genetic things. Hybrid vigor is a big one. Now, hybrid vigor is crossbreeding in animals. I'd always use the example of, you know, if you go up to the DSPCA, you might get a dog there, a cross between a Chihuahua and an Alsatian or something. It's going to be an odd looking thing, but it's probably very hardy, very healthy. It probably outperforms its parents. And think of the pedigree dogs. We've a lovely Labrador Jake at home at the moment, but he's got a bit of a dicky tummy. He's maybe got pancreatitis. He's allergic to chicken, I think it is, was the latest thing we were told. And we have to keep checking his hips because he's pedigree, he's purebred. Sometimes the purebred animals aren't as healthy and as vigorous as those crossbred animals that we come across there. So hybrid vigor or crossbreeding, that's probably something that's practiced on most Irish farms. We would get certain pedigree breeders, but take examples there. Take dairy farming where we'd cross a Friesian with a Jersey cow and we get the best characteristics of both. It's high yielding, it's got good milk solids, it's a slightly smaller, more efficient animal that'll do well on a grass-based system as well. In sheep, we might cross something like a good carcass, and then the Blackface Mountain is very maternal, very good mother, okay, she'll look after her ewe very well. And if we cross those two together, we get a mule, which, and you know, those are what lowland sheep farmers look for. That mule sheep or the grey-faced sheep is a great one to then cross with something like a Suffolk or Texel. Or indeed in pig production, we might cross a landrace and large white together. We have that crisscross breeding that we talk about in those in pig production, where we keep on crossing landrace, large white, and we bring those different genetics in and lead to healthier animals. Artificial insemination. I spoke in health and safety about the issues of having a bull on farm. So bull on farm, there's a safety issue. You've got to house this big animal, but also you're tied to his genetics and tied to his fertility. If we wanted to improve the genetics, if we wanted to grade up our herd quickly, artificial insemination would be a way of doing it. Artificial insemination is when we buy a straw of semen. We can pick from a catalogue from some of the really best yielding cows. We can look at things like performance testing, where they look at the bulls against each other. We can look at things like progeny testing, where they rate their offspring in similar conditions against each other. And we can pick what we feel is the best bull for our system, buy a straw of the semen, much cheaper. You know, a straw of semen might be 200, 250 for something really good. It can reduce in price. Whereas if we were to go out and buy a really top class bull, you could be looking at €5,000 upwards. So that straw of semen, we can use different genetics on a herd. If we had a dairy herd, we could maybe use, you know, an Aberdeen Angus or a Hereford or an easy calving animal on some of our first time calvers. And then we could use a really high EBI, highly productive dairy bull on our best milking cows. So it allows farmers mix and match, get that strategy right with artificial insemination. The big thing with AI is we've got to get our heat detection right. We've got to know when our animal's in heat. And again, you can see how all of these things intertwine. There's our technology again, our heat detection aids, things like scratch cards, things like activity monitors, tail painting, or indeed physical signs that allow us to know the animal's in heat and where we can go from there with it. Genomic selection, this is one that comes up a bit. What is the genome? It's the makeup of an organism's DNA. A genomic selection can take that DNA and it can highlight the genes that might be there for productivity, that might be there for disease resistance. It can look at an animal's genetic merit, okay, and tell us what's going to perform. It's also, we use genomic selection here for traceability. So we can tell where a meat sample has come from. We can trace that right back to the farm, and it's an extra layer of food security there alongside the tagging system. So genomic selection as a way going forward might be how farmers can identify their highest yielding animals. They can see a calf at an early age that's you know, going to be highly productive and really produce for them going forward. Genetic engineering then as well, biotechnology. So genetic engineering, you know, know one example of that. So genetic modification, we don't carry out really a huge amount of genetic modification. We get GM crops in here. Genetic modification would be where we alter the genome, we manipulate the genome, or we add or delete a gene in the genome there. Really, there's not a huge amount of genetic modification carried out on Irish farm animals. There's certain trials in crops looking at things like maybe blight resistance in potato. But CRISPR is a genetic engineering process where we can edit genes. So we can maybe turn off a gene that causes a particular disease or a particular genetic defect or something like that. So having a look over that, over CRISPR and everything that comes with it. I just see sex semen down there as well, okay. Sex semen, I don't know, I have the wrong note underneath it, okay, so apologies, I need to edit that out. What sex semen is there, okay. Sex semen allows, in a dairy herd, okay, a dairy bull is of not any huge use to us. It's not of any financial gain. It's not going to put on huge weight. We don't want that many dairy bulls. In other countries like New Zealand and England, sadly what they do with a lot of dairy bull calves is they shoot them at birth. And we have a 50-50 chance of every time a cow gives calves, okay, that it's male or female. Sex semen through AI increases those opportunities there. We get about an 80 to 85% certainty that it's going to be a female cow. That's going to be much more profitable. It can be used in the milking. It allows for a rapid expansion of our dairy herd there as well. So sex semen in. And sorry, I'll correct those notes and I'll put them in. I just see the little issues there with that at the moment. The other thing I'd probably talk about in that applied biology is embryo transfer, okay? So embryo transfer is where we can get a superior fertilized embryo that's been fertilized in vitro, and we can place that into a donor animal, and she'll give birth then to a genetically superior offspring. So I'm trying with sheep at the moment. I was just talking to Owen, who looks after the sheep alongside me, of buying some embryos in from the UK next year, good Texel genetics. We're going to implant those into some of our good ewes, good mothers, and they'll give birth to good Texel lambs. And it's a cheaper way for us to improve the genetics of the herds, to maybe breed a really good ram, rather than buying very high-priced stock and trying to import it to go to the north, the UK or Scotland or somewhere like that to bring in new genetic lines. Nutrition, okay. I'll have a look at nutrition up on the board here. So really with nutrition, you know, with soil management and everything, we talked about essential elements. We also looked at trace elements as well. And really what I want you to do is sort of track through from soils to crops to animals. If we can get the nutrition of soils right, the nutrition of our crops will be right. If the nutrition of our crops is right, that of our animals is right as well, okay? We get these sort of essential nutrients across all soils, crops, animals. They could be things like NPK, like carbon, like hydrogen, and some of the other vitamins, things like calcium and magnesium. And they're ones that have come up across quite a bit, okay? Calcium and magnesium. If we can get that into soil, into the grass, then we've got calcium and magnesium, which are needed for things like cell walls, okay? Needed to improve metabolism and photosynthetic processes in plants as well. So you can see that in the notes there, okay? Calcium would lead to poor root growth. Magnesium, yellowing between veins, that's more looking at, I suppose, signs of how it would come. Calcium particularly for think of the cell walls in plants there as well. But we can see if we don't have those in our soils, if we don't have them in crops, something like the calcium, okay, a deficiency of it there can lead to milk fever in an animal. So where they just don't have enough calcium coming through in the diet there, okay? Or with magnesium, we have deficiency diseases like grass tetany. So again, that would just be an example of how if we can get nutrition right at the soil level, it's going to be in crops and it's going to make sure animals don't have that deficiency diseases. Another one that we might see there coming across is something like cobalt, okay, and copper deficiency might lead to swayback in sheep. Boron, we talked about our catch crops, that might lead to something like clubroot in kale. So we've got to get the nutrition of our soil right. How do we do that? We soil test, we make sure we have proper nutrients in there. It's not just our NPK, maybe there's trace elements that we've got to get right and we've got to add to our soil. Iron, iron is a thing. Indoor pigs don't get much iron in their diet because they're not outside rooting, and that can lead to anemia. If they're outside, they're rooting around, they're getting iron from the soil, they don't have that iron deficiency, the hemoglobin, the red blood cells working around their body, and it means they don't develop something like anemia. So you can see there, just down the bottom of that, okay, something like nitrogen, how it's used across all the cycles there. So organic matter cycling in the soil, we have our nitrogen cycle. It's needed. Nitrogen is an essential part of protein. Chlorophyll is a protein. We need chlorophyll to photosynthesize, so getting that in there is really important. And we'll see nitrogen then is needed. It forms amino acids. It's part of muscle development. So these elements are needed across soils, crops, animals. Calcium and magnesium I've talked about, cell wall strength, photosynthesis I've talked about with magnesium, and they're needed. Calcium is needed obviously for, think of that old ad, them bones need calcium. Cattle need that as well. They need calcium. They use up a huge amount of calcium in producing the milk. Everything comes with it. Sulfur is an important one there as well. Sulfur comes in organic matter, and often with a lot of the compound fertilizers that we see today, things like NPK, they'll have added sulfur. Getting that sulfur right in soil is really important because, again, we're getting that protein formation. We're getting on top of that and everything that comes with that there as well. So nutrition, another key one there. Keep the questions coming, guys, if you have any. As I said, if there's anything I can answer at the end there, happy to do that. Now, food production in agricultural science. What's the importance of food production? I suppose agriculture is still one of our biggest indigenous industries here in this country. And as an industry, we're heavily reliant on our export market. Sending our food to UK, to China, to the US, and we'll see how those global markets can be affected now in a little minute. But also we're quite reliant on imports, things like fertilizer coming into the country, things that we don't produce here in this country anymore. So what we're trying to do is we're trying to produce safe, nutritious food. Really in this country, what we're really trying to promote is the green image that we come across there. So things like Bord Bia, sustainable beef and sheep schemes, Origin Green, all of those are really focusing in on the green nature we have to our food production systems here, the fact that most of our animals come from a grass-fed diet. And the importance of that is really the unique selling points, the unique taste, the unique everything that makes our agricultural products desirable throughout the world. So you can see there some of the major livestock systems that we look at. Dairy, obviously milk is the big thing, but there's all the subsidiaries from that of cheese, butter, yogurt, cream. I don't know why I have a picture of a steak in there in the end, but listen, I'll get working on my infographics, okay? Beef, it could be beef bullocks, heifers. We have a certain amount of bull beef here in this country as well. So all those fresh cuts that you may be putting on the barbecue as well, steaks. Maybe you like your roast dinner every Sunday, the burgers, mince and everything that comes from beef cattle as well. Lambs, lamb prices are taking a real hit at the moment. The lamb herd is reducing over sheep flock. The national sheep flock numbers are reducing at the moment because they're getting such poor prices in the factory. But leg of lamb there, particularly mince. Wool has taken a real hit. Wool used to make up a huge part of a sheep farmer's check. But I suppose wool has been taken over by synthetic fibres and stuff like that. Pigs, two big things. I haven't put pork in there, but in the written notes you'll see, okay? Pork and bacon come from pigs. Bacon is just salted pork. So the ham you'd eat at Christmas, the bacon that you'd eat on breakfast in the morning or whatever, that is just salted pork. So you could have a pig and one half would be pork and one half, if you salt it, could be into bacon and into hams and stuff like that as well. And pork is the widest eaten meat around the world. Okay, so pig production, it's probably one of our most intensive food production systems here in this country. Still mainly indoor pig production. Okay, it's one of our highest inputs, highest outputs. They get no grant aid. We'll talk about policies and economics at the moment. So they run those pig systems really efficiently. There's never been a long question on pigs on the course. Could be a short question there and things like biosecurity and stuff. It was always the tip for years that we haven't seen it as a long question. I don't think you get a full question on pigs, but just make sure we know about those pig production systems as well. I meant to say with dairy, like we talked about our cheese, butter, baby powder, milk protein, we're actually the third biggest provider of baby milk powder in the world, and a huge amount of that goes to China. And again, a large amount of that comes down to our very green image, okay? We're producing food in, even if it's not totally organic, a very free-range system, okay? A very healthy system, and that appeals to consumers, that appeals to countries. Also, those regulations from the EU, we produce food in a very safe manner. Probably on TV at the moment, I don't know how much you keep up to with topical affairs, but you'll see things about Mercosur deals, these US Trump tariffs. They want us to buy in beef from South American places, but it's not produced to the same food standards. We're not assured that that beef won't have traces of antibiotics and stuff in it, that it hasn't been pumped with water, that the chicken fillets haven't been chlorinated in an effort to kill off bacteria. So I suppose a big area that I didn't put in there, but we don't deal with it in huge detail on the course or really look at it on the course, is poultry farming. And there's broiler farming where we're producing chicken fillets. It's probably one of our biggest selling meats in this country at the moment. And then also egg production is huge as well. So all you lads on your high protein diet and girls on your high protein diet as well, chicken and eggs probably form a huge part of that. I talked about this green image, and grass-fed is really important to us here. Because our animals are mainly grass-fed, or they're fed on silage, which is grass derivative during the winter months, grass-fed animals have a unique taste and a unique colour to their meat, to their milk, to any of the products that come from that animal there. And that's down to a thing called beta-carotene. Beta-carotene, think of carrots, it gives this rich colour to the meat. It gives rich colour to the butter. I always say to my classes, like, think of when you're abroad, maybe I'm going to holiday in France in a few weeks' time. I hate drinking the milk over there. The butter tastes like crap to me, to be honest. It's very different Irish butter because a lot of their milk and butter comes from grain-fed systems or animals that aren't fed on grass. If you get a steak over in America, it's a huge big thing, okay, lovely, but it's not the same as that nice marbling, that nice taste, that really rich red colour that we get from grass-fed Irish beef. So our grass-fed animals are a unique selling point. They give us a much improved taste, they give us a much improved texture, a much improved quality, and that means that we can really harness that to improve our export markets and sell these throughout the world. You'll see just two things you'd need to know about there as well are artisan and niche food production. Okay, artisan, small-scale, traditional, handcrafted foods. Niche production, it's looking for a specific market, maybe something like, outdoor pig production, organic meats or something like that. The emphasis on really high-quality ingredients with each of those, locally sourced ingredients, low food miles, and as I said, foods that are produced in a traditional manner. And in this country, we have a number of foods that have protected geographical status. So actually, grass-fed beef has become this protected geographical status. So to liken to that, in France, Champagne would have PGI status in terms of you can only produce Champagne in the Champagne region. There's certain German foods like Black Forest ham. But over here, as I said, we have our grass-fed beef. We have things like Drimoleague brown pudding, we have the Waterford Blah, we have Achill lamb. All of these have protected status. They're artisan products, niche products. And with these artisan and niche products, if you go down to a farmer's market in Airfield and Dundrum today there, you'll pay a premium because you know that this food has been produced properly, produced correctly, and produced in a manner that appeals to you as a consumer. And our last one there, guys, you can take a bit of a break after this, so you can head back to bed before really settling into the ag science for the afternoon, is economics and policy. So with our economics and policy, we've got, it can be hard. There's so many policies, they change so often. It can be hard to get our head around all of these. But I suppose what I need you to know is general terms, what our economics and policies are. A lot of our policies, all of our policies in this country are directed by Europe. And most of them come under this common agricultural policy. And this was born out in the late 60s, early 70s, when after the World Wars, we had to produce more food. And the push at that time was to produce as much food, be as productive as you can. But we've seen in the intervening time that that's come at an environmental and a sustainable cost. You know, 20, 30 years, 40 years ago, my grandfather would have been told, get rid of the hedgerows. That's where you could be planting wheat or barley. Up your herd, get as many cows as you can. Then milk quotas had to come in. Now, the big push from CAP, from the Common Agricultural Policy, it supports farmers, gives them financial incentives to make sure we're always producing food. But the big, I suppose, metamorphosis in that is we're producing food in a very sustainable manner and an environmentally friendly manner now. So within CAP, funding is produced to farmers every year from the EU funding. And in order to get that funding, farmers have to carry out a number of different measures. Now, some of them might be just financial measures, depending on the amount of land you have, the amount of livestock you have, like the BISS, that's the Basic Income Sustainability Support, to make sure farmers can make a living. Okay, if you have a year where crops are ruined or where sheep prices have gone down through the floor, you've got to make sure that you have a constant income coming in, and something like the BISS supports this. Okay, you'd register with the amount of land you have every year, the farming measures that are taking place on the land, any schemes that you're part of it, and a payment is made accordingly to that. And it ensures for European countries that we have a stable supply of very affordable food there as well. Environmental schemes, they might be something like GLOS, okay, EOS was the old one there. There's different tranches of those come out, and those are incentivizing farmers to carry out environmental measures on their farms. That might be things like replanting hedgerows. It might be the native woodland scheme, where we're planting native trees like birch and alder and oak in unproductive areas of our farm. It might be introducing habitats, maybe ponds, maybe bird boxes, bat boxes, owl boxes, providing habitats to increase biodiversity throughout the farm. Environmental measures might also look at wildflower margins or buffer zones so that we reduce runoff into watercourses and improve water quality. And all of those tie into more environmentally friendly way of farming, more sustainable way of farming, and ultimately decreasing our emissions overall. Infrastructure, things like TAMS, I've talked a lot about the LESS systems, proper livestock and handling from a safety point of view, how we have to get those right. TAMS, the Target Agricultural Machinery Scheme, I think it is, that again would pay anywhere up to 60% of the cost of new machines for the likes of Mintill, for low emission slurry spreading, for improving slurry tanks, housing facilities. There's a whole rake of grants and elements that come there. And farmers, in order to get these financial incentives and payoffs, they have to tie into them. So something like the sheep improvement scheme would be improving sheep health and welfare on the farm. I have to carry out a certain amount of measures, and then I get a payment, I think it's €12, I think it's gone up to maybe €18 this year, of €18 per ewe to make sure that I'm looking after things like scanning, foot bathing, that I'm looking after fly strike control, maybe mineral supplementation and stuff like that as well. As I said, agricultural imports, exports, very important to the Irish economy, but global factors can have a huge part of it. What's really topical at the moment, I suppose, is Trump and all his measures and vetoes and stuff that are coming in place. He's looking to put a 50% tariff on European foods. Brands that are synonymous with Irish and Irish food production, things like Kerrygold, are sold hugely into the US. Irish whiskey, Bushmills, that comes from barley, okay, or Waterford Distillery are places that are producing gins and whiskey that come from Irish barley production. If they've got a 50% tariff put on top of them, they're just not going to be able to sustain that, to bring that. So because we export so much of our food, because we import so much things like fertilizer, we are, I suppose we can have a volatile economy from time to time in terms of costs and the impact that some of these big global decisions make. So you might think Trump across in America, that doesn't really bother me, but a 50% tariff could shut down businesses, and that'll have a knock-on effect on farmers here. So we're constantly looking to new export markets. We send a lot of our products now to the likes of China, to the Far East. We're trying to constantly look for these new markets. Brexit has been another big hit in recent years, but Brexit rules and regulations are beginning to be relaxed a little bit now at the moment as well, okay? So I think there was a stat a few years ago, for every Irish steak sold in Ireland, there's 4 Irish steaks sold in the UK. We send a huge amount of our beef over there, lamb would go over there, So things like Brexit, things like Trump's tariffs, they can all have an effect on that export-import market. And indeed, the Ukraine war was a huge one in recent years because most of our fertilizer came from the Ukraine and Russia, and indeed most of the wheat that we have that may be going into animal feeds and stuff like that came from the Ukraine and Russia. So fertilizer prices went through the roof, grain prices went through the roof. So let's just have an appreciation of the effect of global decisions on day-to-day farming, inputs, costs, and everything that goes with it, okay? So guys, that's about it from me with the cross-cutting themes. As I said, in terms of this weekend, get looking over your SPAs, get looking over your calculations, okay? Go through key areas. I think if you're looking over SPAs, you're covering a lot of soils with that. We did soil management, and that video should be still up on the platform there. We've looked at calculations. There's a video up there. We've looked at animal and plant ID. There's a video and there's notes up there and stuff as well, okay? And then animal production. We've got our dairy, beef, sheep, pig production. In crops, we've got to get that grassland sorted out. Barley is your major food crop, and kale is your catch crop there, looking at it as well. Genetics, we've talked a little bit about today, okay? You know, we've covered a good deal of that, but I think it's unfortunate the nature of the course. We don't have a sort of a guaranteed, we don't know question 2 is going to be on soils every year because of that non-linear level. We've got to have that overall view of it, but there's a few key areas there, as I said, like the SPAs, calculations, whatever, that we can really focus in on. Now, Katie, sorry, you can't see the infographic. I think I sorted that out. They're up now, sorry. So technology problems, but all the notes are up there, okay? So they should be all up there ready to go. Is there enough choice to skip calculations, Noah? Possibly, but I mean, the calculations, I know some of you have a bit of a phobia of maths, but the calculations tend to be relatively straightforward. They tend to be something like averages, tend to be very simple little percentage calculations or whatever. Often if we get a question on beef, there's going to be calculation questions coming there, so we need to make sure we get on top of that. Do you have sheets on animal diseases? Yes, Katie, I can get that up. So I'll make a note of that and I'll make sure that we have that up. In each of the chapters as well on beef, dairy, sheep, there's the animal diseases that they focus in on. So like even today I've spoke about grass tetany, milk fever. The other key one I know with dairy is probably mastitis. You know, with sheep, I spoke about fly strike there, lameness. So trying to know production diseases, notifiable diseases like TB, ones we have to notify to the environment, and then zoonotic diseases, ones that can be transferred to humans there as well. So we'll get something up on animal diseases over the course of today or early tomorrow morning. Holly, what are SPAs? Specified practical activities, fancy name for your experiments or your investigations, and those specified practical activities, they're all up in a notes booklet there online, and there's videos for the majority of those ones as well. Carry them out. Key differences between 2-year calf to beef and suckler. I don't get how to differentiate it. So 2-year calf to beef, it tends to come from the dairy herd. I'll just turn off that screen there for a moment. 2-year calf to beef. Calves originate from dairy herd. Okay, they're taken off mother within 24 hours, and then they're reared on milk replacer, and then those animals are brought right through to slaughter. In suckler farming, it's generally beef breeds. So what we might have is a cow that's a crossbreed. It might be something like an Aberdeen Angus, okay, crossed with a Frisian. That's our hybrid vigor coming through again. So the Aberdeen Angus crossed with the Frisian, we'd have plenty of milk from the Frisian, we'd have good body conformation, easy calving, whatever with the Aberdeen Angus, and we might cross that with something like a Limousin, which is a continental beef breed, or Charolais or something like that. We'd use a terminal sire, a big beefy breed bull with that. The calf stays with the mother. It suckles, and because it suckles, it's got a much higher daily live weight gain. Over here, the daily live weight gain for a 2-year calf to beef, where they've been hand reared and just ate, might be 0.6 to 0.8 kilos. Over here, it's 1.2 kilograms a day with the likes of a suckler animal, and it can be anywhere up to about 80 kilos heavier at weaning. Now, suckler farming is becoming a little bit unpopular in the country here. It predominates a lot of part-time farmers. It's not always seen as the most efficient system, but there's still a market there for these big weaning calves. They can sell those on at sales. They could be much heavier animals at the same date as these animals at second winter coming in when they're weaned off it. There's a lot of work obviously with 2-year calf to beef, but dairy production is such a huge part of the country here. Every cow has to produce a calf in a dairy herd every year. A lot of these are crossbred animals that originate from the dairy herd. We hand rear them, we bring them through. Really, if you were to ask to look at 2 beef enterprise systems, you'd compare suckler with 2-year calf to beef. The initial 6 to 8 months is different in that the calf stays with the mother, it suckles on the mother, whereas over here you're feeding milk replacer, you're gradually introducing concentrates and hay. The mother's looking after most of the diet here in grass. But then from weaning, so from first winter basically, those animals over here are weaned off milk at probably 8 to 10 weeks, but come first winter, these are removed from the mother here, but they're a much heavier, bigger animal. They're going to reach slaughter weights much quicker and stuff like that as well. So those are the key differences there. David, do you need stuff for root crops too, or do you need one of either potatoes or barley? You just need one of potatoes or barley, okay? You're asked to do one food crop and one catch or energy crop. So make sure we know, people always get caught out for a named food crop, give your named food crop. We've looked at barley here. Some of you might have done potatoes in your own classes, okay? But barley is the one that we focus in here on Grinds 360. And then catch crops. They can sometimes be called a break crop as well, okay? But the catch crop that we looked at was kale. So again, you have to pick either kale or an energy crop, Miscanthus. I would stick with the kale because it's very similar in how it's looked after, how it's cultivated and everything like that alongside. So we can cut down, maybe if you're going by your textbook or something, you'll see barley, potatoes, kale, Miscanthus. Pick one of barley and potatoes, pick one of kale and Miscanthus. Adam, do we need to know sheep's, pig and cattle, or just cattle okay? If you're only starting to study ag science now, you'll answer a lot on dairy. I think I would always cover sheep, pigs and cattle, okay? And within cattle, you've got dairy and beef there as well. So there's quite a body to get through. Sheep came up quite a bit in the paper last year. There was questions there on the sheep improvement schemes, mothering ability, synchronization of yos and stuff came through. There is videos up from the Easter revision courses on those there as well. So make sure you have a look over them. All the notes should be in the book as well, the textbook, and that should be broken up online. But if there's anything there that you're unsure of or whatever, as I said, just drop me an email, Ian, IAIN, @grinds360.ie. Connor, do you need to know every experiment? You could take a chance on the ones that came up last year that they're not going to come up 2 years in a row, but there's 20 experiments or SPAs altogether. As I said, there's one there on genetics that looks at hybridization that's very hard to do in a classroom, and famous last words, but I don't think they could ask too much on that because it's a hard one to do, but you need to have a knowledge of that experiment there. As I said, the farmyard layout one is not one that everyone gets to, but Walter has some excellent videos up on the platform there, going around his farm and looking at some of the features and everything that comes with it. Uh, will there be a big emphasis on sustainability in paper? Juliet, at the moment in farming, there's a huge emphasis on the environment and sustainability. You know, there are two cross-cutting themes on the paper. There are two very topical issues in agriculture at the moment: reducing greenhouse gas emissions, sustainable farming practices. So yeah, that was one of the key reasons I went over those sort of cross-cutting themes and things today, was to get through. So I think there will be a big emphasis in those areas. And I said things like technology tie into sustainability, breeding and genetics tie into sustainability. Sustainability is really a sort of a catch-all situation for us there, or terminology. Dara, are the growth cycles of crops important? They're a tricky one, I know, yeah, but they do come up. So with something like barley, grass, I try to cut it down to, and kale, like they're all very similar, of germination, you know, vegetative stage, elongation, and then maybe the flaring stage. With things like grass, we don't want it to go to a flaring stage. With barley, it's that. Try and keep it to 3 or 4 simple stages there, okay? Don't get too bogged down in it. So those are our key bits and pieces, guys. The very best of luck with revision over the few days. As I said, there's going to be stuff pops up in that paper that you might not have seen before. You mightn't have covered in any textbooks, grinds classes, whatever. Take your time, take a deep breath, apply that knowledge, okay? There might be comprehension questions there on a topic you've never seen before. I bet you the answers are in it there, or you've got the answers somewhere else that you can apply that knowledge and bring it through. Think of the key skills like drawing graphs, like the calculations and stuff that we've talked about there as well. And as I said, if there's anything at all that I can help you with over the course of the weekend, I'll be on the email, or indeed you can just get it into the general info email address here, and I'm sure all of that will be passed on to me. So very best of luck with that. Oh, we have another question here. Do you have anything with all the experiments? I do, James. Yeah, there's videos of most of the experiments up on the platform there, and there's also a booklet with all the experiments in there as well. So those would be two good things to have a look at over the weekend. If you don't like to listen to me with the experiments, there's plenty of them up there on YouTube as well. There's plenty of them up on Skullnet. But as I say, we have all the experiments, try to give you a bit of a breakdown, and there's notes on each of those ones there. With the experiments, the key things you'd need to know is, you know, what was your hypothesis, prediction, using that terminology of if I change this, then this will happen. Know how to pick out the independent, the dependent variables, and also would there be any systemic errors, health and safety errors that might have got through it. Generally, you'll be asked to give 3 or 4 points of a method. You're not going to be asked for any specific results, but maybe how you gathered results or gathered data. Thanks, James. All right, Grania, could you make a quiz with all the photos we need to be able to identify, like a word wall? I'll do my best. I think I have a few Quizlets I can send you links to that you go through those, okay? We've flashcards and stuff as well that you could maybe cut out yourself. So Grania, I'll see what I can do. I won't promise anything. But as I said, there's animal and plant ID up there. There's machinery up there. There's notes on all of those. So all of those bits and pieces should be up there as well. How many people get the full 25% for the IAS? Well, really what you're looking at is H1s overall. You don't really get a breakdown with that, okay? It's marked as a full question. It's hard to get 100% in the IAS, to be honest with you, Noah. Katie, do you have to draw the reproductive systems? You could be asked to draw, yeah, you need to be able to illustrate and label the reproductive systems. You're keeping it fairly simple, like, you know, if you were doing the female reproductive system, it's very similar to what you'd have done at junior cert there, guys. So with the female reproductive system, you know, you're looking at ovaries, fallopian tube, you've got the womb and the vagina. You're keeping it fairly simple there. You know, with the male reproductive system, you're looking at the testes, you're looking held outside the body in the scrotal sac, you're looking at sperm ducts, the penis. You know, you're keeping everything fairly similar there. The next teacher will be wondering what's going on the board up here when they come in. Can you use your biology to 100%? Yeah, if there's anything, Katie, that you can cross over with biology there, use them. Nitrogen cycle, carbon cycle, the exact same. You go into greater detail in biology if everything. The big one there in diagrams as well is the ruminant digestive system has come up from time to time. and also the digestive system of a young animal, how it differs a young ruminant. And the big difference with a young ruminant is it has an esophageal groove coming through. Is there key list of definitions? No, it's Ag Science is a newer course, Vic, okay? It's not like biology where the definitions are learnt off. There won't be a huge amount of definition questions on it. You'll see things like outline, explain, list. They're looking at key skills and stuff rather than just rote learning of reproducing definitions. Is there a few definitions within there? Certainly there'll be one or two, okay, but less of that than maybe you're used to in other subjects like biology or business or anything like that as well. Guys, keep the questions coming in. If there's any more questions, stick them up there now, okay? I think I've got to most things there and I've answered most things. All right, so as I said, use your time wisely over the weekends. Make sure you knuckle down and do that. Don't be getting into any Netflix series, okay? Don't waste too much time looking at URC finals and stuff. It's the final push now, and you'll have plenty of time after this to really get going, to burn all those Ag Science books and get rid of them. You'll be done and dusted, okay, on Monday morning. So just make that final push over the weekend to get everything up and running. As I said, anything we can do to help in the meantime, just give us a shout, email in or give us a shout into here. And best of luck with your Ag Science exam and with any of the rest of the exams that you have over the upcoming weeks. Thank you. Another question quickly there from Rian. What are your top 5 experiments to learn? We have covered pigs, sheep and cattle. Would it be okay? Top 5, that's a hard one, Rian, to put me on the spot now with 5 top experiments, okay? But there's a huge amount of soil experiments. There's 10 experiments there, and any questions on soil tend to be based back in on an SPA, okay? So we've got to know our way around those. Is it okay to just revise sheep and cattle? Like, cattle's a very broad term. You've got dairy and you've got beef within that, Katie, okay? I just have a feeling there was a lot on sheep, okay, and we haven't seen a huge amount on pigs on the paper. It's a bit harder for them to ask question on pigs on the paper. So I would I try and give each of them a bit of an overview over the course of the weekend. Vic, thanks very much. David, would you be better off looking through the book and syllabus or looking at the exam papers? Like, we have a textbook here with Grinds 360 that we've tried to keep fairly succinct and just the information that you need. I think some of the textbooks can be very wordy and contain a lot of extra information. For me, at this stage, I'd be looking through plenty of exam papers, but also have the marking schemes side by side with them, David, and you know, go through a question, look at the marking scheme, amend your notes, amend your thoughts on that. Look at the sort of exam technique of where they say, you know, outline or explain what sort of detail they're looking for there. Look at the key points that come up time and time again. You'll begin to see patterns and familiarity with those questions there. All right. So last chance now, guys, on a few. So if that's not, I think I've said best of luck now a few times to you. All right. So you know that I'm behind you on this one. All right. Very best of luck with everything. And as I said, give us a shout if there's anything at all. But for now, goodbye.